In this video, we will review Chapter 9, and Chapter 9's review begins on page 616. I have a couple of problems chosen from each section, written with a couple of the directions. So we'll be going over those solutions and how to tackle those problems in a couple different ways. So the very first section, 9.1, find the sum or difference. So we're going to be adding or subtracting here, and I'm going to tackle these two problems a different way. So for the first one, I am adding. All right, first of all, I'm adding, so that is like multiplying each of these terms in the second set by a positive one, and then adding all of the terms together. All right, so I'm going to actually use a vertical method to add these. So I'm going to rewrite 11y to the fifth plus 3y squared and then minus 4, leaving some spaces for blank terms here. And then I am adding, so I put a big plus sign over here to the left, a y squared, making sure to line up my terms, minus y plus 1, and then I draw my big line underneath. Alright, so 11y to the fifth is not being added to another term with a exponent of 5. But here I have 3 plus 1y squared, so that is 4y squared minus y, and then a negative 3 plus 1, or sorry, negative 4 plus 1 results in a negative 3. So that would be if I were to line them up vertically. That is my final answer. 11y to the fifth plus 4y squared minus y minus 3. In this second example here, I'm going to line them up horizontally and just leave them the way that is. I am going to distribute that negative sign, so it is like multiplying every term by negative 1. So I'm going to rewrite it. Negative k squared plus 7k plus 5 minus 2k to the fourth plus, because a negative times a negative is a positive, plus 3k to the third plus 6. And then I'm going to reorder them and group them in decreasing exponential order. So I have negative 2. This is going to be equal to negative 2k to the fourth and plus 3k cubed minus k squared plus 7k plus 5 plus 6. Alright, so here I actually only have two terms that I'm going to end up combining, and those would be my constants. So my final solution here is going to be negative 2k to the fourth plus 3k cubed minus k squared plus 7k plus 11. Alright, sometimes we can't combine too many terms and we end up with a huge long line. That's alright. Alright, 9.2. Find the product. So here I am going to be multiplying. And either we have two binomials, or we are having a binomial multiplied by a larger polynomial. Here it's a trinomial. And we're going to need to use our distributive property. Alright, so here I want to distribute my x into every single term. This is called left distribution. And then I'm going to distribute that negative 3 and multiply each of those terms by negative 3. In a different approach, you could distribute that x squared to both of those terms and use right distribution here, and then that negative 2 to both terms, and then that positive 1 to both terms. Either way, you're going to end up with adding 6 multiplication problems. So here I'm going to use left distribution. Alright, now I'm going to get x cubed minus 2x squared plus x. And then when I distribute that 3, that negative 3, I get negative 3x squared plus 6x minus 3. Notice how I lined it up vertically. You, of course, can line it up horizontally. Then I add my terms together, and I get x cubed minus 5x squared plus 7x minus 3. And that is my final answer. to this multiplication problem. All right, my next example, I do have two chunks here with two terms, so I'm multiplying two binomials, so I can use the FOIL method. So let's multiply our first terms. 4n times 7n is 28. I'll go ahead and write this a little bit lower. 28n squared. Oh, outside. All right, and that is a 4n times negative 3, negative 12n. I inside. Negative 5 times 7n, negative 35n. And then L last. Negative 5 times negative 3 is a positive 15. Then combine your like terms. 28n squared minus 47n plus 15. And that is your final solution. Okay, in 9.3, we want to find a special product here. So you have 2x minus y quantity squared. So when I say quantity squared, what that means is I actually have this quantity twice. So 2x minus y times 2x minus y. Alright, and so we want to go ahead and do this, which is called expanding. Alright, this is an expansion. And then you can use the foiling process. If you do remember a shortcut, there is a pattern to this because this section was entitled Special Products. So you are finding special products. This is a binomial squared. And this will produce what is called a perfect square trinomial. So we take whatever this first term is and we square it. Alright, so I'm just going to write 2x and then I'm going to put squared. And then we have whatever this second term is all the way here on the end, negative y squared. Alright, plus negative y squared. And then I take the product of these two terms and I double it. So plus 2 times 2x times negative y. That's the shortcut. So you square both of the terms, then you multiply them together and you double it. So 2x squared, that's 2x times 2x, or 4x squared. And then you end up with a positive 4x times negative y, gives you a negative 4xy. And then a negative times a negative, or a negative squared, is a positive 4y squared. And that is your solution. If you remember these shortcuts, it can get quicker and easier for you, so you don't have to go through the entire foiling process. Alright, so our next example. This is what is called a difference of squares after you multiply it. In this section, it's called a sum and difference pattern, and it produces a difference of squares. So if you recognize, alright, I've got a 3s and a 3s, but this is a plus 5 and this is a minus 5, it's going to produce a special product. Alright, so that pattern is you go ahead and take your first term that you have, alright, 3s, and you square it. And then put a big old minus sign. And then take your second term and you square it. And that should be what you get. You can go through the entire foiling process, but you would see that that plus 15s minus 15s would cancel out. So your result should still be 9s squared minus 25. You can go through the foiling process. It's just going to end up a little bit longer than if you remembered the shortcut. Alright, moving on. 9.4. Solve the equation. So here I am going to be factoring. Alright, so instead of multiplying like we did in the last 3 sections, I am undoing that process and I'm factoring. So here you want to find a common monomial between those two terms. So I've got 2a squared plus 26a, and I recognize not only are both of these coefficients even, but they also both have an a to spare. So I'm going to undistribute a 2a. Alright, now when I undistribute a 2a, that is like dividing each of these terms by 2a. So, how do I get 2a squared when I am undistributing a 2a? I'm just left with an a, and then 26 a divided by 2a gives me plus 13. Alright, and you can always double check that by distributing and making sure that you get your original here. Alright, that still equals 0. And it's important to remember I need this to be set equal to 0 because I'm going to use what is called the zero product property. I have to have these set equal to 0. So, if two things are multiplied and the result, the product, ends up being equal to 0, one of the things I'm multiplying, one of the chunks, has to be equal to 0. So I'm going to set them both equal to 0. 2a equals 0 or a plus 13 equals 0. One or the other. Well, I need to solve both of these. And I divide by 2. 0 divided by 2 is 0. A equals 0. So that is one of my options. And then I subtract 13 from each side. And I get a equals negative 13. Alright, these are my two solutions. And I can write it a little bit differently. A equals 0, comma, negative 13. You could say negative 13 or 0. You can say and. Doesn't really matter. Either way, they're both solutions. Unless you were talking about a real life problem, then we need to add in some critical thinking with restrictions here. Alright, next problem. Just like I said, we need this baby to equal 0. So we need to move all the terms to the one side. So I'm going to go ahead and subtract 7h from both sides. Now, this is an h squared, and this is an h. Those are not like terms. So, you need to make sure that you are not combining them. Alright? The 7h's do cancel out here. So this is 21h squared minus 7h equals 0. They are not like terms. One is an h squared, one is an h. It's different. Alright, so now we need to find the common monomial that we can factor out of both of them. What do both of these terms have in common? And that is a 7h. Alright, 21 is divisible by 7 and results in a 3. If you take one h away, that leaves you with 1h. And then 7h, if you undistribute 7h from 7h, you get 1. Alright, reversing that multiplication process. And then you use your zero product property, and you set each of these chunks equal to 0. 7h equals 0. 3h minus 1 equals 0. And then you solve both of them. So divide by 7. H equals 0. That is one of your solutions. Add 1 to both sides. 3h equals 1. And divide by 3. H equals 1/3. Oh no, it's not a perfectly even number. Too bad, so sad. It's okay. 1/3 is still very nice. So your final solution is going to look something like h equals 0, 1/3. 0 and 1/3. Alright, it is not a point. Do not put parentheses on there. They're two separate points. Okay. My next section here, factor the trinomial. So I am going to be undoing this whole multiplication process we went through in the first couple of sections. Alright, so a couple of checkpoints that we got to look at first. I do have all of my terms in order. That meaning x squared x and then my constant. My leading coefficient, this number right here. What is that number? It is a equals 1. Alright? When a equals 1, that makes your life a lot easier. Alright, so here's the process you need to go through. A equals 1. Alright, cool. Let's go ahead and look at the factors of c that add to b. So what multiplies to negative 32? Of course, you can say 1 times negative 32. Alright, but you add those together, you do not get 4. So let's look at some closer factors here. What about 2 and negative 16? Nope. Alright, let's go on the other end. Let's make the bigger number positive because it's going to result in a positive. How about 4 times negative 8, or, negative 4 times 8, switching it up. All right, well, negative 4 times 8 does give you that negative 32. Well, negative 4 plus 8 gives you that positive 4 for your B. All right, that is what we want. So what that means for us, x squared plus 4x minus 32 is equal to x minus 4 times x plus 8. And that is how you factor when a equals 1. Alright, so let's look at another example. N squared plus 15n plus 26. Alright, what are the factors of a positive 26? I've got 1 and 26, I've got 2 and 13, I've got a negative 1, negative 26, negative 2, negative 13. Think about all your options. Alright, which multiply to 26 and then add to a positive 15. And that would be, ding ding ding, positive 2 times positive 13. So, n squared plus 15n plus 26 equals n plus 2 times n plus 13. Well, Miss Hlebiczki, can I write it like this? N plus 13 times n plus 2. Why, certainly. Of course, either would be correct. Alright, that's just using your commutative property. Alright, so that is how to factor if a equals 1. Notice that leading coefficient was 1 again. And how can you double check? Well, you can always double check by, foiling. Alright, there's nothing against double checking yourself. I highly recommend it. Alright, next section. Solve the equation. Alright, so we are taking this one step further. We are going to be factoring, but then we're going to be using the zero product property. So let's go ahead and, add that 4r squared onto both sides here, because we need this to equal 0. 0 equals, writing in order, 4r squared plus 18r plus 18. Okay, what do you see that you don't like? That's going to be that 4 out in front. So let's see what we can do to maybe, lower that number, reduce it as much as possible for you. So, can I factor out a 4 of all of these terms? No, but I can factor out a 2. So 0 equals 2 times the quantity, 2r squared plus 9r plus 9. And this is where you need to start thinking about a factor of not only a, now that a is 2, but the factors of a and c that somehow multiply and add terms to get to b. Alright, so you of course can, write out your full table here, like we did in that section, or you can start to think critically here. So 0 equals 2 times. That 2 is just going to remain there out in front. Don't worry too much about it. Alright, now the factors of 2. Just thinking about the factors of 2. There are only 2 factors of 2. And that is 1 times positive 2 and negative 1 times negative 2. We're just going to work with the positive case because that's a little bit easier. So we're going to say r times 2r. Okay, and then we need to think about all of these factors of 9. So the factors of 9 are, 1 and positive 9, negative 1, negative 9, 3 times 3, or negative 3 times negative 3. And then you can substitute in these values and do a kind of trial and error, or maybe you can think critically about it. So I'm just going to, test out an option and see if I get lucky. Alright, so let's do plus 3, plus 3. Alright, that's going to give me a positive 6, and that's going to give me a positive 3r. So plus 6r plus 3r. Alright, and does that give me my middle term here? It does. It gives me that 9r that I want. Alright, so I didn't really get lucky. I've done this a lot, so I know what I'm doing, but if you write out a line of work, like I have on the right out here, and you do the math for the middle terms here, and you get plus 2r, and then you get plus 9r, and that gives you plus 11r. You can start to think, okay, maybe those numbers are too high, or you can cross off the negative ones because these products are going to end up negative, and this is a positive number. Think about it critically and see if you can narrow down. And you can always FOIL these to double check. So, getting rid of this work here, I need to solve it. Alright, the bottom line is that I need to solve this problem. So I need to use the zero product property and set these equal to 0. So r plus 3 equals 0 and 2r plus 3 equals 0. And we are going to ignore this number out in front. It's not really important unless it has a variable right by it. Alright, so you subtract 3 and get r equals negative 3. And then you subtract 3 from this one, and you get 2r equals negative 3, and r equals negative 3 halves. Alright, so the two answers are both negative 3 and negative 3 halves. A little bit more work than you're used to because you had to get everything on one side, you had to factor out a common monomial, and then you actually had to go through the full factoring process. Let's go ahead and look at a word problem. You throw a ball into the air with an initial vertical velocity of 46 feet per second. The ball leaves your hand when it is 6 feet above ground. How many seconds does the ball land on the ground? Sounds a little bit complicated, but if you write down, box it, make a note of it, you should have this formula. H equals negative 16 t squared plus vt plus s, where h is your height at a certain time, t is that time, v is your initial velocity, and s is your initial position. Alright, your initial height. So, identifying these numbers here. So, 6 feet above the ground. Alright, 46 feet per second velocity here. And then there is another keyword all the way at the end. When it hits the ground, how many seconds? So, we are searching for time. So, we will not be plugging in anything for t. We need to plug in these numbers. So, vertical velocity is 46. I know that goes in for the v. I'm not plugging in anything for t here. And I want to know how many seconds it takes. Alright. When it hits the ground. Well, what height is the ground? That is 0. So my ending height is going to be 0. And my initial height is that 6. Alright, so I look at these terms and I recognize what they have in common. And they all have 2. So I'm actually going to go ahead and factor out a negative 2 just because it's going to be easier to have this leading coefficient be positive. So 0 equals negative 2, 8t squared minus 23t minus 3. And now I have this trinomial that I am trying to factor. Alright, so I know that I have many factors of 8, but I don't have too many factors of 3. So you can fill out this chart where you have the factors of A and the factors of C and the possible factorizations. Alright, this is what your table is going to look like, and let's go ahead and come up with a couple of possibilities here. So, factors of 8, you've got a 1 and a positive 8. You have got a 2 and a 4. And let's go the negative route here. You've got a negative 1 and a negative 8. And let's go ahead and I'm changing all of those, so I'm going to go ahead and try to, keep consistent here with my factors of negative 3. So I've got 1 times a negative 3 1 and negative 3, 1 and negative 3, and it could be a negative 1 and a positive 3, so then those would be, more options and more arrangements, all right, in which you assign the negatives to a different one, or you switch the order, which one's in the left and the right set of parentheses here. So, with that being said, the way this is going to look is I've got t plus 1 times 8t minus 3. Alright, and you would continue all of these arrangements and realize that when you multiply these middle terms, 8t minus 3t equals 5t, that these options aren't going to work out for us until you get to a line that looks like this. So, you flip around your signs, you flip around the values, and eventually I get to t minus 3 times 8t plus 1, and then I finally get that middle negative 23t. Alright, so I need to go back to my original problem. Alright, our whole goal here was to use factoring to solve this. So I have factored. Here's my final factorization. Negative 2 times t plus 8, and it should be t minus 3, sorry. T minus 3 times 8t plus 1. Alright, using my zero product property, I set each of these equal to 0. T minus 3 equals 0. T equals 3. Alright, so how many seconds after the ball lands does it hit the ground? And that would be 3 seconds. Alright, the reason why I'm going to disregard this second solution is that when I set it equal to 0 and subtract and divide, I get a negative solution, and it would actually be t equals negative 1/8, and that's impossible. I can't have negative time. Alright, so yes, a little bit of a heavy factoring process here, and that is all because a is not 1. It's a lot easier when a equals 1. Alright, last one here. Section 9.7, factor the polynomial. Alright, so I want to make these numbers smaller if I can. 12 happens to be a factor of both of them. So let's go ahead and factor out a 12. That leaves me with 1 and a 4n squared. Alright, this can be factored further. I see an n squared and I want to factor it further. That is a difference of squares. Alright, and what happens with the difference of squares is I kind of take the square root of each of those terms and I put a plus or minus. So what's the square root of 1? That's 1. What's the square root of 4n squared? And that would be 2n. So here goes a 2n, here goes a 2n, then I'm going to have a plus or a minus. And if you don't believe me and if you don't recognize the pattern, then FOIL it out and double check yourself. Alright, next problem here. I see a 100, I see an x squared, and I recognize this is a perfect square trinomial. Alright, so if I am to factor it, I can go about the regular way. What are the factors of 100? That add to a positive 20, and that would be a positive 10, positive 10. So this is, yes, it's x plus 10 times x plus 10, but that's not how we're going to write it. We're going to write it as x plus 10 squared. We're factoring that perfect square trinomial. And one more word problem. You drop a penny from a height of 16 feet. From a height of 16 feet, that's my initial height. After how many seconds does the penny land on the ground? So, yet again, I have this formula. Alright, and this 16 is my S. That's my initial height. I've got ground in here again. That is 0. That is my H. H equals 0. I am looking for seconds, so I'm still not replacing my T. T is what I'm solving for. I don't have velocity. Well, it said you dropped it. Did you throw it with some velocity, some speed on it? No, you didn't. So velocity here actually equals 0, which is really nice value for it. So substituting in all those values, negative 16 t squared plus 0t plus 16, that disappears. And if you add 16 to both sides, negative 16t squared to both sides, you get 16t squared equals 16. Divide by 16. This is a little bit of a different approach. And you get t squared equals 1. You take your square root. Now I want you to be very careful here. When you take the square root of something squared, you need to make sure you have plus or minus. So t technically equals plus or minus 1. Alright, so your actual solution here is t equals 1. So 1 second. Your solution is 1 second. If you drop a penny from the height of 16 feet, after how many seconds does the penny land on the ground? 1 second. And our absolute last section here, 9.8. Factor the polynomial completely. Alright, I've got two terms, and 147 looks a little big to me, so let's see if we can factor out a common monomial. I know that I can take out an n cubed, that's going to help me. And then I see that 3, and I know I can only take a 3 out of the second term, so I might as well take a 3 out. Alright, and that results in 49, n squared minus 1. And I can still factor this. It is a difference of squares. 3 didn't magically turn into a 2. 3n cubed. And that becomes 7n plus 1 times 7n minus 1. Alright, that is a pattern that you need to memorize, write down, note, and study. Okay, here. I still have 3 terms. I see a 60, that's too big. I see z's in all the terms, and I see that they're all even. So let's start out by factoring out a 2z. That results in a z squared plus z minus 30. Now I can go about a regular factoring process. Alright, what are the factors of negative 30 that add to a positive 1? So let's try out 6 and negative 5. 6 minus 5 equals a positive 1. 2z. Z plus 6 times z minus 5. Alright, and that is the complete factorization. There's 3 different chunks there. Alright, so if instead this were to say solve, it had this set equal to 0, you would have to take each of these and set it equal to 0. Alright, but here it just says factor. Alright, and our last final example of this review, I have 4 terms. And if I see 4 terms, I should think factor by grouping. Alright, so I line all of my lovely terms here in order: b cubed, b squared, b constant. Alright, and I identify my 2 groups. Here is group 1, here is group 2. And I want to factor out their greatest common monomial. So here it is a b squared for group 1. That results in 2b, or not 2b, plus 3. And then keep your signs in mind. I've got a negative 8 and negative 12. Negative 4 is what they have in common. So when I undistribute that, I factor out the negative 4. I get 2b, a positive 2b, plus a positive 3. And now, out of these 2 chunks, these 2 groups, they both have a 2b plus 3 in common. So here is that 2b plus 3. And then my result in my other set of parentheses is going to be that b squared minus 4. Am I finished? Is everything factored completely? Well, this is down to just a b, so that part's good. But b squared minus 4. That is a difference of squares. So one more line. 2b plus 3 doesn't change. This factors into a b plus 2 times a b minus 2. And that is the complete factorization. Alright, if you have any questions, feel free to re-watch this video, re-watch the section videos, and email me with questions. Good luck studying.